because the speed of light is same in all initial reference.
Ah, wow. It's something to do with the speed of light. Yeah. Okay, speed of light. Okay. So we have several reasons, yeah, several reasonings to this brain teaser. Then we'll see afterwards, yeah, whether which one of you, give the, let me say, acceptable reasoning, yeah, as to why it happens. Acceptable reasoning to this question, because this is a typical question, yeah, that's being asked by Galileo to himself. Whether it is same for moving observer with stationary observer. I mean, these kind of things that you should learn, yeah, to inculcate in yourself and say why. Well, if this is the case, what's going to happen? And what is the reasoning? Is the reasoning reasonable? I mean, these are the things, the skills that you should inculcate in yourself in this course. Alright, so before I can give you what is the answer. Okay, there are several things that you need to know first. Oh, okay. So you need to know what does it mean by event, what does it mean by reference frame, These are the two important determinants, that will help you find reasons, to the questions just now. And then I'm going to illustrate to you, the Galilean transformation for position. How do we relate, the measurement of one individual with another one in a moving object? And lastly, if you have enough time, we will solve at least one of two of these problems. Okay, so there's basically three objectives for our telesidang today. Okay, let's go to the event and also reference frame, So that is our flashing light just now, So these flashing lights, we call it an event. If you look inside your textbook, page 1151, 1151. Oops. 1151. Okay, 1151. So that's a definition for event, You can have a look at it, and then normally I use a highlighter to highlight it. Things that are important. So it says that what? An event is a physical activity that takes place at a definite position in space and at a definite instant of time. It's something that happens. Page 1151 in your textbook. Your thick textbook. Okay. So an event is something that happens. It can be an exploding firecrackers. It says here. It can be a collision between two particles. And also it can be a light wave hitting a detector. As for my case, I just use a flashing light. Okay. Because it is a very fundamental entity in relativity, something about an event. So it can be a flashing light, it can be a firecracker exploding, it can be a volcano erupting or something like that, an event. So it's something that happens at a certain position and at a certain time. Okay, something is wrong with this computer because all my letterings has gone haywire. This is not supposed to be like this, but well, be it then. Okay, let's say we have our stationary observer just now, So this stationary observer is going to make measurements, for the position of this event. Remember our event just now? So this observer can assign a space-time coordinate for the event. I hope you still remember the coordinates. Sometime in your secondary school before, your x and y axis, your coordinate, your x coordinate, your y coordinate, your z coordinate. I hope you still remember that. Yeah, because we are going to use that one again, yeah. So let's say this person measure the position as x and the time that is occurs as t, time. And then our moving observer just now, moving with constant velocity relative to the first one. So it measures the position using the symbols x prime. So in this case, whenever you see a prime means it denotes a moving observer. Measurement being done by a moving observer. And T prime, whenever we use it, meaning it denotes some prime, some symbol with the prime means it belongs to the moving individuals, objects, or something like that, yeah? So that I don't have to say it again and again. Okay? So now we back to our square one, yeah? Is the position of the flashing light the same for both stationary observer and moving observer? Or mathematically, we can write is the space-time coordinate, the x, the position, and the time, t, equal to the position as measured by our moving observer and the time measured by the moving observer. Is it the same, yeah? And our question, brain teaser just now, is the position the same, yeah, for both? So what I'm showing you now is we are using the coordinates, to indicate, the position and also time. So this is how we write it down, Okay, let's do this one. And how is the stationary observer going to make the measurement for position? So remember when we say coordinates, our x and y coordinates, that you normally use during primary school. During your secondary school, we have the y-axis and x-axis to denote the origin, isn't it? From where you made the measurement. I hope you still remember your x and y. So this is your y-axis and this is your x-axis. Okay, and then the origin, to make the measurement. And of course, when you say something about the x and y-axis, okay, you need to have your grid, isn't it? So you remember? Things that you have learned before, you are going to use it again. Of course, we need to have our clock here, isn't it? To measure time. So that is the measurement for position. So what is the, let's say one box represents 1 meters. So where is the position of our flashing light now? Let's say one box represents 1 meter. So our flashing light, the position is? Okay, Ramzi, what is the position for our event, our flashing light?
8 meter.
So 8 meters, isn't it?